Assalamualaikum and greeting to everyone. My name is Fazli bin Asyamin and we are from the Bachelor of Science Mathematical Modeling and Analytics, course code CS267. Today we would like to present our linear algebra 2 group project entitled Best Fit Curve Analysis on the total death in Malaysia using the least square method. The main objective of this project is to determine the most suitable mathematical model that best represent real life data using the least square approximation method. In this project, we analyze the annual total number of deaths in Malaysia from the year 2000 until 2019. The data used in this study were obtained from the Department of Statistics Malaysia through the Open DOSM portal. The dataset consists of yearly recorded deaths in Malaysia over a period of 20 years. In this analysis, the independent variable X represent the year while the dependent variable Y represent the total number of deaths. To simplify the calculation and avoid using large value, the years from 2000 until 2019 were transformed into values from 0 to 19. The data were chosen because they show a clear increasing trend over time and are suitable for best fit curve approximation. Besides that, this dataset provides a meaningful real-life application of linear algebra and least square method in analyzing demographic trends. Next, we applied three different mathematical models, which are the linear model, quadratic model, and cubic model to determine the best approximation for dataset.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arif Rahman bin Ahmad Rizwan, and right now I will be presenting about linear model for annual deaths. For linear model, its equation line is y equals a plus bx, where a is the constant, which is what the y-intercept, and b is the gradient. Okay. By setting up the data points into a matrix system, we will obtain a matrix equation like this. And then after solving the matrix equation using the least square method, we will get the value of a and b. After that, we will be subtracting the product of the coefficient matrix and the parameter matrix from the result vector. By that, we can obtain the error vector, and then we will calculate its magnitude using a formula. And then for the linear model of annual death, this is the magnitude error from the data. Alright, after getting the constants, which is y-intercept, and then the gradient, we can graph the equation, which will look like this. As we can see from the graph of the projected total deaths, the linear is increasing as years goes by. Alright, next, using the error vector, we can map the residuals against the corresponding years to construct a residual plot. As we can see from the graph, the error value hovers around 6,000 and negative 6,000. Alright.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Hazman bin Muhammad Zamri. Today I will explain the quadratic model used in this project. The quadratic model is represented by the equation y equal to a plus bx plus cx squared, which is the value of a, b, and c are the constant that need to be determined using the least square method. Similar to the linear model, the data were arranged into matrix form and solved using Maple software. After solving the system using the least square method, the value of a, b, and c have been identified. Next, we subtracting the product of the coefficient matrix and the parameter matrix from the result vector, and we obtain the error vector. After that, we calculate the error magnitude using the formula, and the value has been identified, which is the error magnitude is 5.9499 multiplied by 10 the power of 6. After that, as you can see, this graph represents the quadratic approximation model obtained using the least square method. The curve shows an increasing trend over time, which indicates that the number of deaths in Malaysia increases gradually from year to year. Unlike the linear model, the quadratic model is able to represent the curvature of the data more efficiently. Lastly, using the error vector we obtain, we can map the residual against the corresponding years to construct a residual plot. Residuals are difference between the actual data values and the predicted values generated by the model. As you can see from the graph, we can observe that the residual values fluctuate throughout the years. Since the residual do not vary too drastically, the model is considered reasonably suitable for representing the data trend.
Hi, Assalamualaikum. My name is Muhammad Irfan. So today I will present a cubic model. So the linear regression model is y equal to a plus bx plus cx square plus dx cubic. So we setting up the data point in the matrix. So we obtain mv equal to r, where it could be this 1,480 ABCD and 177C. So we need to solving this using a maple, so that we can get a value of the ABCD. So the value of ABCD is a negative 1.8 multiply of 10 of power of 11. So the B, the value is a negative 9.206 multiply 10 power of 7. The value of C is a 5263.68, and the D value is a 10.5804. So continue the other page. So by subtracting the product of the coefficient matrix and the parameter matrix from the result vector, we can obtain the error vector. So we magnitude yields using a maple, using a least square, using a error vector. So we use a R minus MV. So the error magnitude that we can get is 3.1457 multiply 10 power of 11. So continue the other page. This page this is graph. So we using the result by a least square solution in the first page earlier. So when we do this, that we can get the modeling total debt over the year. So in this graph, it's not be acceptable because we start from a negative y, and approximately it's not correct because when we use the other model, they start with positive, so this cannot be accepted. So continue the page that we need to using the error vector, so we can get a map of the residual against the corresponding years to construct a residual plot. So this is a negative relationship between error and year, because in the early 2000 the error became very high, 7.2 multiply 10 power of 10. So when the 2020, the error became a 0. So that's all for me. Thank you.
Lastly, I will explain the cubic model together with the analysis and conclusion of this project. The cubic model is represented by the equation y equals to a plus bx plus cx squared plus dx cubed. This model is more flexible because it includes the x cubed term. Similar procedures using the least square method and maple software were applied to determine the coefficient of this cubic equation. After obtaining the equation, the error vector and magnitude of error were calculated and compared with the previous model. The cubic model is able to fit the data very closely due to its flexibility. However, a more complex model does not always guarantee the best representation because it may lead to overfitting. Based on the comparison of all three models, we found that the quadratic model gives the best approximation for this dataset. This is because the quadratic model produces a smaller error magnitude while maintaining a smooth and realistic trend. In conclusion, the least square method is very useful in finding the most suitable mathematical model for real-life data analysis. Through this project, we were able to apply concepts for linear algebra such as matrices, transpose matrices, and least square solutions in solving practical problem solving real data. Thank you.